So this go round, we're looking at a certain type of force. What type of force? Friction. And yes, it's important, as you can see by even the polar bear slipping on the ice. So what is friction? Well, friction is a force that resisting the relative motion of surfaces from sliding against one another. That sounds a little complicated still. So friction basically is always going to resist motion, and it's caused by things being in contact with one another. The term being a surface is a little confusing because we do have a fluid friction, and what's reacting against each other is the surface of air. And you don't always think about it that way. It's still a true statement, but just keep an eye out for that thing. So it's what allows you to walk around. It keeps you from sliding. That's why when ice is out, you trip and fall a lot. You have things like if you've ever been given a friction burn where somebody rubs your arm, it can hurt because it's two surfaces, the hand and the arm, being pulled against each other. So we're going to look a little bit more in depth at a couple of types of friction. First type, static friction. Static friction is what you think about when you see an object not moving. So I used to have a truck that broke down a lot, and I would have to push it out of the road. Well, it was always much harder to get it started moving out of the road than it was once I had it going. And that was because the static friction locks it in place, causes its inertia to be greater because it actually is a force acting on it that keeps it from starting to move. Once it starts to move, I don't have static friction anymore because it's now moving. Static's only for it not moving. If you've ever tried to remove a refrigerator, it's really hard to start moving a refrigerator. Once you get it moving, it'll kind of slide. But at first, it's really tough because it has a high static friction. Next up, fluid friction. That's basically the resistance of liquids or gas. If you've ever had a boat or gone canoeing, you've dealt with liquid friction. So you've had to move it through the water, and you had a fluid friction acting on it. Gas, well, think about like a parachute. Parachutes wouldn't work without fluid friction, meaning the parachute is pushing against the gas. Sliding friction, well, that's the resistance created by two objects sliding, usually large objects, or not large objects, but solid objects. So we're not dealing with a liquid or a gas anymore. But think about once that refrigerator is moving, it's now just sliding on the ground. So there's still a good bit of friction there. And then last we have rolling friction. And that's what allows our cars to go so smoothly is their own wheels. It is actually the smallest or the least of all the frictions. That's why the invention of the wheel was such a big deal. It greatly reduced these other frictions, giving us a very small friction so things could move easier. But none of this would be possible without the normal force. Normal force is just a fancy term because remember when we were talking about Newton's third law about equal and opposite reactions? Well, that's where we get a normal force. I didn't have a name for it. I called it the force of the floor, but it's really the normalizing force. It's what keeps things from falling through other objects, you falling through your chair. It is a third law force, but it's basically just equal to whatever is being pulled down to keep it going through two objects. That normal force, though, means you know exactly how hard two objects are pushing against each other. And that's what's going to give us our friction. So the normal force is what we use to figure out and calculate all of the frictions that we look at, except for, well, to a certain extent, even fluid friction. So that boat sitting in the water, that water has a normal force acting back on the boat. So it still would even work there. So I guess, yeah, it's used in all of them. To give some quick examples of these frictions, the static, not moving, if you took a microscopic look of things, no matter how smooth they look, they would really be jagged. And that's what static friction really is. Those grooves sit in one another and they don't want to push past each other. Sliding friction, we're now getting that stuff hitting each other and moving along, but it's already started, so there's a certain amount of inertia that keeps it along with that. All right, so sliding, think about sledding. Static, something sitting still. Best idea I can give you for fluid friction, parachuting. Just grabbing that air, it's causing that resistance, and that's what keeps you from plummeting to your death. Rolling friction, well, that's why we use things like a dolly. It's a lot less friction for that wheel to roll than it would be to slide the boxes, okay? It would even be less than it would if they're just sitting there. So rolling friction, lowest friction.